No, it's not showing anything. Anything as in I can see my I can see myself and the share screen that I've added. Am I going to be seen in the live or it's just my voice? No, not showing. Anything as in I can see my I can see myself and the share screen. Now I can hear my voice repeating. Added. Okay. Am I going to be seen in the live or it's just my voice? I can I can myself and share. Now I can hear my voice added. But am I going to be seen in the live or it's just my voice?
Okay, so hello everyone. Welcome to Swiflearn. So today we are going to be learning a grade 9 portion, which is atoms and molecules. Now, before we go forward, do not forget to subscribe to our channel and also hit the bell icon to receive any updates. Okay, so let's begin with our portion today, which is atoms and molecules. Now, the main objective of today's class is welcome to Swiflearn. So today we are going to be learning a grade 9 portion, which is atoms and molecules. Now, before we go forward, do not forget to subscribe to our channel and also hit the bell icon to receive any updates. Okay, so let's begin with our portion today, which is atoms and molecules. Now, the main molecule. Just a second, hold on. Okay, so today we are going to learn atoms and molecules. Well, before we get into atoms and molecules, we'll have a quick recall on what we learned in the previous two chapters. Yes, atoms and molecules is the third chapter. So you need to have a little bit idea of what you learned in the previous chapter. So that, yeah, so quickly we'll have a quick revision on what is matter and what are the important things we learned in the previous two chapters. And then we will learn about two laws. These are called as the laws of chemical combination. So we will be learning about laws of conservation of mass and the law of constant proportion. So this is a brief explanation of what we are going to do today. Yes, so are we ready? Let us start. Well, now quickly recalling what we learned in the previous two chapters, we learned the definition of matter. Yes, so what is matter? Matter is everything that has mass and occupies space. Yes, so anything that we are looking, when we look around, everything consists is that is made up of or has a mass and occupies a space is called as a matter. Yes, the screen that you are looking into right now is a matter. The table on which your computer is placed is a matter. Yes, the pen and the notebook that are using to make down notes is a matter. So anything that has mass and occupies space is called as a matter. Is that clear? This is the definition of matter. Now, there were many scientists who came up with a lot of theories on what a matter is. How do you, when you break open a matter, what do you see? Yes, we know in the previous chapters, we learned that there are three states of matter. Remember? Yeah, what are the three states of matter? One is solid, liquid, and gas. Yes, matter exists in three states, which are solid, liquid, and gas. So many scientists came up with theories on what matter is made up of. So long ago, that is about during the 6th century, an Indian philosopher called as Mahashri Kannad was one of the first person to suggest that matter is made up of tiny particles. Okay, so matter was called as padarth, okay, was named or called as padarth, and these tiny particles which made up the matter were called anu. Yeah, so padarth was made up of so many tiny anus. Yes, and these anus could be further divided into more smaller particles, which is called as parmanu. Yes, and these particles, that is the parmanu, is so small that they cannot be further divided. So we could say that parmanu are indestructible. Indestructible meaning they cannot be further divided. Or another term you can use for this is indivisible. Yeah, indivisible meaning it cannot be divided further. Yeah, so we learned that Mahashri Kannad, who was an Indian philosopher, suggested that matter, which is also called as padarth, is made up of small tiny particles which are called as anu. Yeah, and these anus could be further divided into smaller particles which is called as parmanu. So anu have independent existence. That is, they can exist as an individual anu, whereas parmanu are the smallest particle and it does not have an independent existence. Clear? So so basically there's a lot of parmanus which combine together to form anus. Yeah, so parmanus are the smaller particles which combine together to form a bigger anu. Yeah, later came a Greek philosopher called as Democritus, who termed parmanu as atom. Okay, now the word atom was derived from the Greek word meaning atomos. Okay, a Greek word atomos meaning indivisible. Indivisible means what? It cannot be further divided. It is so small that it cannot be further divided. Okay, so later there was a Greek philosopher who named or who termed parmanu as atoms, and atom was derived from a Greek word atomos. And what is the meaning of atomos? It means the small particle that cannot be further divided, or we could say that atoms are indivisible. Clear? So moving forward, later came another French chemist named Anthony L. Lavoisier. Okay, so Anthony L. Lavoisier experimented more deeply into the concepts of atoms and molecules and formulated two main laws. These laws are called as law of chemical combination. Yeah, so these laws had changed or made history in the field of chemistry. Okay, now going a little more deeper into, before we go a little more deeper into studying these two laws, first let us recall what is a chemical reaction. Well, in lower classes, we learned that there are two kinds of reactions or two kinds of changes. Yeah, yes, one is physical and one is chemical. Now, what is the difference between a chemical reaction and a physical change? It means that in a physical change, no new substance is formed. Right now, basically, if I take a paper and if I tear the paper into two, so I get two papers, right? So there is no new chemical product or a new chemical substance is not formed there. So that is a physical reaction or a physical change has happened there. Yeah. Now let us try to learn what is a chemical reaction. Now imagine you are taking an acid. Can you come up with an example of acid? Yes, HCl. HCl is a very good acid. So you take HCl, you take another base. An example for base would be NaOH, that is sodium hydroxide. When I mix both of them, what happens? A neutralization reaction happens there. Yes, I'm taking an acid, taking a base, and reacting both of them to get a neutralization reaction, and a new compound is formed, that is sodium chloride, NaCl, or salt is formed. Yeah. So in this particular chemical reaction, a new substance is formed. Yeah. So it is termed as a chemical reaction. So whenever in a reaction a new substance is formed, it is called as a chemical reaction. Okay. So coming now back to the two basic laws. Now we know what is a chemical reaction. Yes, when a new substance is formed from the reactants. Now, basically in a chemical reaction, you have a reactant and you have a product, right? Whatever is written on the left hand side is a reactant. The reactant combined to form a product, which is usually written on the other side of the arrow, that is on the right side. Yes. Yeah. So now the next major question was, does the mass changes of the reactant, because a new chemical product is formed, right? So does the mass changes between the reactant to a product? Yeah. To understand more about how the mass changes in a chemical reaction, Anthony L. Lavoisier came up with an experiment. So what did he do? He took a conical flask. Yeah, I want you all to create a mental image of what experiment we are doing. Okay, so take up a conical flask, and into the conical flask you add copper sulfate. Okay, that is CuSO4. Okay, so you add copper sulfate and then you add water into it and mix it. So what do you get? You get a copper sulfate solution. Yes or no? You took a conical flask, you added copper sulfate, and then you added water. You mixed both of them. What do you get? You get a copper sulfate solution. Yeah, which is blue in color. And then another test tube. Anthony L. Lavoisier took another test tube of sodium carbonate, that is Na2CO3. Sodium carbonate, Na2CO3. Now, so he has prepared sodium carbonate, he has prepared copper sulfate in a conical flask. Now, with the help of a thread, he tied the mouth of this test tube of, as you can see here, he has tied the mouth of the test tube containing sodium carbonate, and he has immersed this test tube into the solution, into the copper sulfate solution. Okay, in such a way that both of them are not mixing. Okay, you can pay attention here. Both of them are not mixing here. He has just taken conical flask, he has taken copper sulfate. Into this, he has just immersed the test tube of sodium carbonate in such a way that both of them are not mixing. Now he weighed this. This entire setup was weighed by a weighing machine, and let's say about X grams. Okay, we don't know the exact value for it, so we are keeping X as a value. So this setup was about X grams. Okay, now he tilted the test tube a little, okay, in such a way that there was mixing of copper sulfate and sodium carbonate. Okay, And then again, he weighed this entire setup in a weighing machine, and it was found, surprisingly, it was found that here also you got the same value. The weight was same, that is x grams. Okay, so before the reaction it was x grams, and after the reaction also it is x grams. Okay, so what did you observe there? You took copper sulfate, which is CuSO4. You took sodium carbonate, which is Na2CO3. That is the reactant. You mixed both of them. You get a green colored product, which is copper carbonate and sodium sulfate. And it was observed that both of them have the same mass. So with this observation, we can come up with a conclusion saying that mass remains the same in the reactant as well as the product. The mass remains the same. So based on this observation, Anthony L. Lavoisier came up or stated a law which is called as the law of conservation of mass. And what does this law states? It states that mass can neither be created nor be destroyed in a course of chemical reaction, though it may change from one form to another. Let's dig deeper. In a chemical reaction, as you saw earlier, right? You took copper sulfate and sodium carbonate, you mixed both of them. So those are the reactant, right? To get, we can go on, yeah, to get copper carbonate and sodium sulfate, right? So this was a chemical reaction that took place, and it was seen that the reactants and the products are same mass. There was no change in mass. So based on this, we came up with a law that states that mass can neither be created nor be destroyed in a chemical reaction, though it changes its form from one form to another. So I hope that the law of conservation of mass is clear. Okay, this is a law of conservation of mass. Yeah, now let us try to know that whether we have got the concept clear, for which I'm going to give you a question. Try to answer the question. Okay, so in a reaction, you have taken 5.3 gram of sodium carbonate, okay, and you're reacting it with 6 gram of acetic acid. Okay, so these are the reactants. 5.3 gram of sodium carbonate and 6 gram of acetic acid is the reactants. You are getting, when you mix both of them, you're getting product as 2.2 gram of carbon dioxide, 0.9 gram of water, and 8.3 gram of sodium acetate. Okay, so these are the reactants and these are the products. Now you need to tell me, is this statement following the law of conservation of mass? Okay, how will you do that? You will just add the total mass of the reactant, and then you will add the total mass of the product and see if both are equal. If both are equal, well and good. It is following the law of conservation of mass. But if both are not equal, then such a statement is not possible. Yeah? So let us try to see whether both the mass are correct. So you took this and you're adding. So 5.3 plus 6 gram, you get 11.3 gram. Okay, now let us check the products. Here also you get 11 gram. So is this statement in accordance with the law of conservation of mass? Yes, it is. Okay. So now let's move on to the next law, that is law of constant proportion. Now, before we move on to the law of constant proportion, we need two basic knowledge to be clear that we have actually already learned in our previous chapter. We'll try to recall them. What is elements and compounds? Try to recall what is an element and what is a compound. Well, element is a pure substances that are made up of a single type of atoms. Yeah, like there are about 118 elements that have been discovered till date. How do you know that? You can just go and see the periodic table. All the elements are jotted down in the periodic table based on their atomic number and chemical properties, right? So there are about 94 naturally occurring elements and 24 synthetic elements that are present in the periodic table. Okay. So elements, examples of elements would be iron, hydrogen, calcium, yeah, neon, fluorine, all these are different kinds of elements. Now atoms make elements. Yeah. Now for example, if I take carbon, carbon is an element, yes or no? Yeah. So you took carbon element, and if you see the atoms, or if you observe the atoms inside carbon, you will see that all are carbon atoms. Yeah. So all carbon atoms make a carbon element. All copper atoms make a copper element. All oxygen atoms will give you oxygen element. Getting the concept? So atoms, a group of same identical atoms joined together to give you an element. Yeah, so you can say that element is a substance which is made of only one type of atom. Clear? I'm repeating it again. What is an element? Element is a substance which is made up of only one type of atoms. Is that clear? Now, let us understand what is a compound. Now, we know that atoms combine, same atoms or identical atoms to combine to give an element. Now, different elements or two or more elements combine to give you a compound. The best example would be water molecule. Yeah, water is a compound. H2O is a compound. How? Because it is made up of two different elements. What are the two elements? One is hydrogen and one is oxygen. Yeah. So these two elements combine together to give you, in a fixed ratio, they combine together to give you compounds. Now you must have noticed I use the word fixed ratios. What do you mean by fixed ratio? Now H2O, it makes one water molecule. Yeah. So now that is two atoms of hydrogen and one atom of oxygen. Yes or no? Now, wherever you go, whichever part of earth you go, water, the formula for water would be H2O, right? If I take two different buckets of water, will here be HO and here be H2O? No. Always water, it's constant. Yeah, the compound or water, the formula of water is always constant. That is two atoms of hydrogen and one atom of oxygen. So that is what I meant by saying atoms combine together in a fixed ratio of whole numbers. Okay, fixed whole number ratio to form a compound. So now what is the ratio here for water? It is 2:1. How is that? Two atoms of hydrogen and one atom of oxygen. Yeah. So how can we formulate the definition of compound? We could say that when two or more elements combine together chemically, okay, in a fixed ratio, we get a compound. Is that clear? Now moving forward to the law of constant proportion. Now, Lavoisier and other scientists observed that many compounds were composed of two or more elements, okay, and such compound had the same elements in the same proportion, irrespective of where they were found, how they were prepared, irrespective of all these things. It was seen that always compounds were made of two or more elements, that is in the same proportion. Yeah, like for example, now if I take water, okay, we are now talking in terms of the mass. Okay, so we are taking more water. Now what would be the ratio of mass of water? Now we take H2O is the formula for water. Let us calculate its ratio of mass. How do you do that? You take hydrogen. What is the mass of hydrogen? 1. Okay, 1 is the mass of hydrogen. What is the mass of oxygen? It is 16. Okay, 16 is the mass of oxygen. Now, in a water molecule, you have how many hydrogen atoms in it? You have 2. Yeah, right? So 2 is to be the ratio. Yeah. So now 2 is to 16. If you divide, you will get 1 is to 8. Yes or no? So what is the ratio of mass of water? It is 1 is to 8. Clear? How did you get that? You calculated with the masses. You took hydrogen, the mass of hydrogen is 1. So you took 2 hydrogen, right? Because there are 2 atoms of hydrogen making a water molecule. So 2 is to, the mass of oxygen is 16, right? So 2 is to 16. If you divide both of them, you will get 1 is to 8. Clear? So this is the ratio of mass of water. Now let us see another example, which is ammonia. Now ammonia, the formula for ammonia is NH3. Now what is the mass of nitrogen? The nitrogen mass is 14. And what is the mass of hydrogen? Hydrogen is 1. There are 3 molecules. Like as I said, the formula is NH3. Now ammonia is made up of 2 elements, that is nitrogen and hydrogen. How many nitrogen? 1 nitrogen. How many hydrogen? 3 hydrogen. Okay. So what is the mass of nitrogen? It is 14. Yeah, is to 3. How do you get the 3? Because 1 hydrogen mass is 1. There are 3 hydrogen atoms. So it is 14 is to 3. Is that clear? Now, wherever you go in the world, wherever you go, ammonia will always be NH3. Yeah, however you make it, in respective of how the preparation method was, irrespective of all these things, ammonia, the formula for ammonia is always 14 is to 3, the ratio of mass. Okay. So now here we could see that there is a fixed proportion there, right? It is fixed, right? The ratio is always fixed, right? Based on this, based on this, the law of definite proportion or constant proportion, it is the same thing. Okay, law of definite proportion and law of constant proportion is the same thing. So in exam, if they are asking you constant proportion or definite proportion, you write the same law. Okay, and it was formulated by Anthony L. Lavoisier. Now what did the formula state, the law state? It stated that in a chemical substance, the elements always present in definite proportion by mass, that is H2O, it is always definite, right? The mass is the ratio is 1 is to 8, which is always constant or definite. Yes or no? It is also called as Proust law. Okay, so once again I'm repeating it. In a chemical substance, the elements always present in it are in definite proportion by mass. Clear? Now moving on to the next topic, which is the Dalton's atomic theory. Well, we will learn a little more about who is Dalton in our previous, in our, further slides. For now, you learn that Dalton came up with these atomic theories based on a lot of experiments. Dalton came up with these atomic theories, which were called as Dalton's atomic theory. Okay, now these theory provided an explanation for the law of conservation of mass and the law of constant proportion or the law of definite proportion. Now, what was Dalton's atomic theory? Now, there were few postulates that were set by Dalton. Now, number one is all matter is made up of small indivisible particles called as atom. Okay, once again, all matter is made up of small indivisible particles. Okay, indivisible matlab it cannot be broken down further. Okay, so all matter, whether it is your computer screen or your pen or your dress or your chair or the air around you, everything is made up of matter, right? And these matter, what are these matter made up of? It is made up of small indivisible particles called as atoms. Okay, that is the first postulate. Moving on to the second postulate, atoms can neither be created nor be destroyed in any chemical reactions. Okay, it cannot be created nor it cannot be destroyed. Years ago, how many atoms were there in the world? Currently also the same number of atoms are there in the world. Okay, atoms can neither be created nor be destroyed in any chemical reaction. Now, moving on to the third postulate, atoms are the smallest unit that participate in a chemical reaction. So, whenever there's a chemical reaction, it is atoms that are participating to convert the reactant into the product. Okay. Now, moving on to the next postulate, which is atoms of a given element are identical in mass and chemical properties. Now, what does that mean? Now, you take an element, say oxygen, okay? Now, inside oxygen, you will be having atoms of oxygen, right? What is an element? Element is made up of the same kind of atoms. Yes or no? So you take oxygen. Oxygen element is made up of oxygen atoms. Yeah. So now all these atoms will be same in mass, right? And their chemical properties also would be same. Now, if you take the case of hydrogen, hydrogen is made up of hydrogen atoms. Yeah, hydrogen element is made up of hydrogen atoms. Their mass would be same. That is one is their mass, right? Their mass would be same, and chemical properties of all these atoms would be same. Clear? Now, the next postulate is the opposite of the previous postulate. That is, atoms of different elements have different masses and chemical properties. Same element will be having same identical mass and same properties. Different element would be having different mass, different chemical properties. How is that? Now, if you take two cases, you take hydrogen and oxygen. Now, oxygen will be made up of oxygen atoms which has different mass and different chemical properties. Hydrogen, on another hand, is a different element. So it will be made up of hydrogen atoms which will have totally different masses and chemical properties compared to oxygen. Yeah, getting an idea? Now, moving on to the next postulate, that is, atoms combine in the ratio of small whole numbers to form a compound. Yeah. Now, take the case of hydrogen and oxygen. Hydrogen and oxygen combine in a fixed ratio, that is H2O. That is 2:1 is the ratio of the atoms, right? So 2:1 is a fixed ratio, and they combine as two atoms of hydrogen, one atom of oxygen combined to give you one molecule of, or one compound of water. Clear? Now, the next or the last postulate is the relative number and kinds of atoms are constant in a given compound. That is, if you take water molecule, wherever you go, this water molecule would have the fixed ratio, that is 2:1, hydrogen 2, oxygen 1. Clear? Now we will have a little extra facts about John Dalton. Now, John Dalton was born in a poor weaver's family. He was born in England in the year 1766. And it was very surprising that he started his career as a teacher at the age of 12. Right? So at the age of 12, he started his career as a teacher. That is, he began teaching in the age of 12. And 7 years after that, he became a school principal. Yeah. Now, he spent most of his life teaching and researching in this field. And in the year 1808, he presented his atomic theory that we learned right now, right? We learned the Dalton's atomic theory, right? So that he came up with this postulates in the year 1808. Okay. And this postulate, made history in the field of chemistry, or in the study of matter. It was basically like a turning point in the study of matter. Now, there was one major limitation in the law of constant proportion. The major limitation was that, are you familiar with the concepts of isotope? Yeah, what is an isotope? Isotope, yeah. So isotope is meaning same element with same number of protons but different number of neutrons. As a result, they have different number of mass. So what are isotopes? Isotopes are the same elements. So they have the same atomic number, but they are different in their mass number. Okay, same atomic number, but different mass number. Now, we'll try to understand what is an isotope with an example. Let's take an example of carbon. Okay, now what is the atomic number of carbon? It is 6. Okay, the atomic number of carbon is 6. Now, what is how do you know the atomic number? It is the number of electrons or the number of protons in an atom is its atomic number. Okay, once again I'm repeating, atomic number is the number of electrons or the number of protons in an atom is the atomic number. So that means that carbon has 6 electrons, they have 6 protons. Clear? Now they have the same number of same atomic number, but they have different mass number. How? Because their number of neutrons is different. Now neutrons and protons are present inside your nuclei of an atom. Yeah, so they have 6 protons, but they have different neutrons. Different, they do not have 6 neutrons, it is different. Okay, so like examples would be now carbon 12, carbon 13, carbon 14. There are different kinds of isotopes of carbon, that is based on their number of neutrons. Okay, summing it all, isotopes are elements, same elements which has the same atomic number, but they have different mass number. And why do they have different mass number? Because they have different number of neutrons in it. Okay, the same element or same element, but different number of neutrons. Okay, so this law of constant proportion was not applicable for isotopes. Okay, so that was one major limitation of the law of constant proportion. Now let us see if the concept is really clear. Before we get into checking it, once again we recalled what is matter. Matter is anything that has mass and occupies space. Yes or no? Then we learned 2 laws of chemical combination, which was stated by Anthony L. Lavoisier, which is law of constant proportion and law of conservation of mass. Yes. Then we learned about Dalton's atomic theory, the different postulates that Dalton came up with all these experiments. Okay. So now let us check if you've really gotten the concept clear. So question number 1, which postulate of Dalton's atomic theory is the result of law of conservation of mass? Think. It is nothing but mass can neither be created nor be destroyed. Yeah, all matter is made up of small indivisible particles called as atoms, and atoms can neither be created nor be destroyed in any chemical reaction. Clear? So that is your answer. Moving on to the next question. Which postulate of Dalton's atomic theory can explain the law of definite proportion? The last postulate. Yes, which one? The relative number and kinds of atoms are constant in a given compound. That is, if you take water molecule, that is H2O. Yeah, H2O is a compound. And what is the ratio of mass? 1:8. If you take ammonia, that is NH3, that is formed by 2 elements. Which one? Nitrogen and hydrogen. What is the ratio of the atoms in it? The ratio of atoms is 1:3, right? 1 nitrogen and 3 hydrogen. But what is the mass ratio? It is 14:3. How do you get that? Nitrogen mass is 14, hydrogen mass is 1. There are 3 hydrogen atoms. So 3 into 1, you will get 3. So 14:3. Is that clear? So we have come to an end of today's live session. I hope you all enjoyed it. Yeah. Quickly, we'll have a quick recall. First thing is matter. What is a matter? Matter is anything that has mass and occupies space. Then we learned about two main law of chemical combination. Now, who formulated the law of chemical combination? It was Anthony L. Lavoisier. And what are the two laws? It is the law of conservation of mass and the law of constant proportion. Now, do you have any doubts? Do you have any doubts? You can ask me doubts in the chat box. I'll clear all your doubts. Yeah, go ahead and ask me any doubts if you have. Any doubts, students? Please be free to ask any doubts. Okay? Yeah. Yes, Anthony? Yeah, what is the doubt? Please send it to me as a question, either in Hindi or in English, whichever language you're comfortable in. Now, who formulated the law of chemical combination? Any doubts, students? Please be free to ask. Okay, so I'll wait for another 1 minute to see if any doubts have been asked. Okay. Reducing friction. Please make sure you ask doubt related to what we learned today. Okay. Friction is a completely another chapter which we will definitely do. We will definitely do friction, and also in the comment session, please do tell me the other chapters that you find difficult. Please do tell in the comment session. Okay. We will definitely consider taking those chapters. And also do not forget to subscribe to our channel and hit the bell icon so that you never miss any update about live sessions, about online personal classes, one-to-one sessions, revision classes, all these. If you don't want to miss any kind of update, do subscribe to our channel. Okay, we do have a doubt. That is law of conservation of mass. Okay, now law of conservation of mass states that mass can neither be created nor be destroyed in any chemical reaction. That means millions of years ago, how much mass was there in Earth, right now also that much mass is there in Earth. Okay, mass can neither be created. Matlab you cannot make new mass, neither it can be destroyed. Okay, if you take a chemical reaction, how much of a mass is there in the reactant side, that much mass would be there in the product side. Okay, mass can neither be created nor be destroyed in any chemical reaction. That is the law of conservation of mass. Is it clear? Is it clear? Come on, please be free to ask me any doubts. Others, do you have any doubts? Ask me. Is it clear, by the way? Did you understand the law of conservation of mass? Any more doubts, students? You can ask me any doubt, okay? Based on what we learned today, be free to ask any doubts. Don't hesitate at all. Okay, consider this as a golden opportunity and ask any doubts. Even if it is a very basic question about what we learned today, also go ahead and shoot your questions. Okay, you will not be able to understand unless your foundations are clear. So any basic questions, be free to ask. Yeah, so we have another question, which is explain matter. Okay, so matter basically we learned in the previous two chapters. Okay, now matter is anything that occupies space and have mass. Now, for example, I take this pen. Okay, now this pen, it has a particular mass, right? It has a particular weight, yeah, and it is occupying a space, right? This much space it is occupying, yes or no? So this is a matter. Understood? Matter is anything that occupies space and has a mass. Now if I take example of this notepad, okay, now this notepad, it has a particular mass. Yeah, it has a particular mass and it is occupying this much space. It is occupying. Yes or no? It is occupying this much of space, right? So it is considered to be a matter. So matter is anything that has mass and occupies space. And what is matter made up of? Matter is made up of tiny, tiny particles, which is called as atoms. So anything that you look around you is made up of atoms. Clear? Clear? So this is all about matter. Matter is anything that occupies mass and anything that has mass and occupies space. And there are three states of matter. That is, it can be, you can see matter in three different states. That is solid, liquid, and gas. Shoot examples for it. Give me a solid. All metals are solid, right? It is a matter. Or this book is, or this pen is a solid matter. Now liquid, water, juice, these are all liquid state of matter. Okay, now gas is the air that you cannot see around you, but we are covered with air, right? So this is a matter and this is gaseous form. So this is also a form of matter. Oxygen gas is there, hydrogen gas, all these gases are also matter. So matter is three states: solid, liquid, and gas. Okay, it is clear. Fine. Okay, so I think we are done with the session. Finally, is there any more doubt? Go ahead and ask me, or I'll end the session. Please give me a thumbs up if you have understood, a thumbs up or anything, like just so that I know that you have no more doubts and the topic is like crystal clear. Give me a thumbs up, or just say yes. Just say yes. So I'll get to know that it's clear and then we can end the session. Also, it is not that this is just, we have not taken the entire chapter. This is just the first part of the chapter. The remaining parts of the chapter will also be taken, okay? For which you need to subscribe and click the bell icon to know. It is the remaining part of the chapter will also be taken in this week only. So to never miss an update, do click the bell icon. Okay, so we have thumbs up. Cool. So I will see you all in the next session wherein we will continue this chapter. Okay, we are not going to go unless it is, this chapter is like crystal clear for you, and any questions related to this chapter comes in your exam, you will be able to answer easily. Okay, so we will complete the entire chapter slowly, and be free to ask any doubts. Unless you ask a doubt, it is your loss. If you do not ask it out, it is your loss. So make sure you grab this opportunity and make use of it properly. Yes, clear. Okay, fine. So we have thumbs up. So thank you all for joining. Okay, I hope you all enjoyed as much as I enjoyed teaching you people. So thank you so much, everyone. We'll meet again in the next session. Okay, bye-bye. Thank you, Aditi. Thank you so much. I'm happy that you have understood. Thank you.
Okay. Can you please share your screen now?